I'm guiltygyoza. Today I'm here with my co-founder Ken Ho. We are extremely excited and proud to present you Shoshin. Origin. So Shoshin came from a very long, slow internet, winding road of soul searching and experimentations.
Whoa, internet worked.
Okay, right. This is October 2021. We knew that rich digital realities that are strongly decentralized will be the future, and we want to be one of the shepherds of that future. So our first foray into verifiable compute involved creating physics simulation and Q-learning agents and a tiny deep neural network that are entirely running in the Cairo VM. Then spring of 2022 came, and we conceived of Shoshin, which is an asynchronous two-dimensional fighting game that runs in the Cairo VM. It's a game where player plays by designing dynamic situational behaviors that combat other player-created behaviors. It was incredibly exciting for us, but its prospects seemed so challenging and so multifaceted that we decided to put this project on the shelf and move on. So then we made ASYNC in summer of 2022. It's a fully on-chain game that is the combination of multiplayer factorial and a three-body physics simulation problem. ASYNC, as a game, suffered. It suffered in many ways. It wasn't the right game design pattern, in our opinion, for blockchain as a medium. It has a game loop that requires successful coordination among strangers across time zones to be fun at all. And our team was inexperienced in the way we managed complexity and the way we managed execution. So then came fall of 2022. We made Mumu. Mumu is a simulation game that is asynchronous, meaning that you can experience the game without interacting with the blockchain at all, while the game loop runs verifiably in the Cairo VM. It's the same game loop that exists on chain on the Starknet rollup. Mumu ran beautifully, and our ambition grew. We decided to pick up Shoshin. We decided that we want to knock Shoshin out of the park, and today we are excited to present you Shoshin.
Before we really talk about Shoshin, I think understanding that we wanted to have with everyone is to understand what medium we're trying to simulate worlds on. So if you look at chess game, it's a board, or board games. It's a static. You don't change anything. It's just there. And if you play chess, it's a humanity's way to simulate the world that we can think of and play within that simulation, which is hosted by the medium. And whenever we see this medium on which the worlds can be hosted changes, a lot of fun things happen. And also the limitations and also the imaginations that you can simulate on the medium changes. So that's what we mean by the worlds or the games need to be native to the medium that's being hosted. And what we kind of think about Ethereum or any kind of blockchain worlds, I think there are two very interesting aspects that comes from this new medium. First, it's a multiplayer computing platform. So any kind of computing platform that you have right now is a single player. Your phone, your computer, no one can simultaneously log in and use that computing platform and share the resource that way. So that's a fascinating one. And the second one is that this computing platform never dies or never logs or shuts off. So there's a guarantee of that perpetuality in there. So it's a multiplayer computing some medium, and it never shuts off. So that's where we're getting really fascinated, because if you think about there's a guarantee of perpetuality. Like whatever you do over there in that medium, in that world, it will be there as long as you believe that the computing platform exists. So it's worth for you to do something over there because it's additive. And second, for the first time, this computing device can be use with other people at the same time. So, and I think that's very similar to our world that we're living in. But in order to really think about that, we need to kind of abstract what we really mean by world. So at Topology, what we really believe is that a world is a reality inhabited by beings, not human beings. We don't really mean it's limited by human beings, but it could be any other beings. It could be non-living or living beings. And what we really want to do is that, okay, it's a reality and there are lots of beings. It could be humans, animals, or it could be rock or whatever. It's over there, but we really need to understand, like, what are these beings really do? So when we really think about it, these beings constantly strategize. Like even if you look at the I don't know, atoms, like they always go for least resistance, like from point A to point B. And then for humans, like even I over here are strategizing so that I can deliver the message as succinctly and effectively as possible. So we're playing this strategy game in a times billion times, and that constitutes the world. And that's why we want to call it a minimum viable reality. So if you really minimally look at the reality, these are just, from our opinion, it's an amalgamation of billions and billions of strategies. And we wanted to see, like, how can we actually effectively put these strategies on chain? Because yes, we have this wonderful idea that we want to put worlds or realities on chain that will outlive our lifetime and put standards over there. But at this time, and I think at the understanding of topology ourselves, is that yes, that future is there, but we don't really know how to get there. And what we wanted to do is that how can we actually look at the most fundamental and the most basic layer and components and master that part and then slowly grow out. So yeah, strategies are something that we think is the most basic and rudimentary component of this reality. So that's where topology comes in. That's how we thought about, came up with Shoshin, and I think we'll dive right into the Shoshin and how this is a minimum viable reality that we want to call it with asynchronous on-chain strategies.
So what is Shoshin? As a game, Shoshin is an auto-fighting game that resembles Street Fighter, where two characters are put in a 2D box and they fight each other. But unlike Street Fighter, Shoshin is primarily asynchronous, meaning that you play not by smashing your keyboard, your console, but you play by designing your fighting strategy. And what is a strategy? A strategy specifies dynamic situational behavior. Strategy is what you would do in different situations. As a pattern, Shoshin is asynchronous. The entire game loop of Shoshin is written in Cairo 0 and runs in Cairo VM, which is emulated by Lambda class's Cairo RS, and it's wasmified so that it runs in your browser. You can experience Shoshin entirely in your browser, the exact same game loop, exact same smart contract, without touching the blockchain. As an architecture, Shoshin is a computer. Under the hood, player-created strategies are represented as finite state machines, and the transition functions between these states are represented by binary expression trees. The parsing and execution of these machines are written in Cairo. And as a milestone for the ecosystem, Shoshin pushes what is possible with Cairo VM and verifiable computation. Because we are obsessed with the future of verifiable compute, the making of Shoshin is how we express that obsession and that love. And finally, as a mission, Shoshin is a project that attacks the Photoshop of AI problem. So the Photoshop of AI problem is a problem that haunted the game industry for a very long time. And I think it's not resolved. We believe that a fully on-chain game is wherever going to be a genre of great impact, it needs to solve really, really difficult game design problems. And if blockchain were to prove itself fundamentally a new medium for games, it's really important that we don't shy away from challenges. So we decided to fight this problem that's called Photoshop of AI. It's a problem formulated by Chris Hecker in his 2008 GDC talk. Game AI, or autonomous behaviors that are dynamic, situational, interactive, they make game worlds feel alive. But the making of these game AI has been the privilege of game AI programmers at game studios. So the problem is, how do we design an interface and a system of abstractions such that non-programmers can create rich game AI in the same way that people that don't understand computer graphics, people who don't understand signal processing, they can create amazing graphics using Photoshop. So here's a little bit about our design methodology. We think Photoshop of AI is really a hard problem. Some projects are tackling this problem by throwing machine learning at it. We think that machine learning is statistical in nature, and a trained model is considered a black box. We want players to have direct visibility and editability into the nitty-gritty of the behavior, so we're taking a different approach. With Shoshin, we want to give players direct control of every little bit of their strategy, and on top of that, we want Shoshin to be enjoyed by people who have never programmed a computer in their life. So we need to give them a palatable language to describe rich dynamic situational behavior. And there's a concept in theoretical computer science called Kolmogorov of complexity. So Kolmogorov of complexity of a piece of text, is the size of the minimum computer programs given a language that can output that text. So for example, given a binary sort algorithm, if you want to write in brainfuck, right, the Kolmogorov complexity of this algorithm will be super sky high. But given JavaScript, the complexity is substantially lower. So with Shoshin, we want to design a language for the player to create strategies with the Kolmogorov complexity minimized as low as possible. Now, we are aware of a few dangers. So we are aware that we must not be tempted by the desire to faithfully replicate all these amazing fighting games. All of them are in an evil tournament. Street Fighter, Tekken, Guilty Gear, Dragon Ball FighterZ. However brilliant their game mechanics are, they were born from design paths optimized for real-time play. Shoshin is not real-time play. It is true that we started from game mechanics similar to these, but we need to find our way. And so we derived a methodology which guided our game design process. It is a seesaw between two polars. One polar is the reduction of Kolmogorov complexity. So y-axis is minus k. X-axis is the other polar, which is increasing game depth. 2 months ago, we overhauled our Shoshin editor interface, resulting in a massive reduction of k. 1 month ago, we took a lot of pleasure into expanding the movesets of characters and throwing in air juggle capability, throwing character specials and taunts. So we're going right. We're having a little bit more depth now. There's a long way to go, and we are thrilled to continue down the path. And this project couldn't have been possible without our team of amazing members and our collaborators. So thank you all for the love and dedication you put into Shoshin. If you're a little bit interested, join our Discord. Let's play Shoshin together. Thank you.